When a massive oak tree bursts out of a small seed and rapidly expands its roots and branches, it's difficult to see where all that physical mass is coming from. It can look as though the growing plant is simply conjuring new physical matter out of thin air to build its leaves, its thick trunk, and the sugar needed to survive. However, the law of conservation of matter dictates that this is impossible. Matter can never be created or destroyed. It only changes form. This creates a contradiction. If the universe forbids the creation of brand new atoms, we have to explain how the plant physically builds entirely new, energy-rich substances. The tree relies on a universal recycling process called a chemical reaction to transform existing matter, perfectly accounting for every single atom involved in the growth. A chemical reaction is a process where substances interact by breaking apart and rearranging bonds to form different substances. These starting materials, called reactants, include carbon dioxide and water. The new substances produced are called products, which for the plant are glucose and oxygen. While the reactants and products have completely different physical properties, they are built from the exact same pool of original elements: carbon, oxygen, and hydrogen. Scientists document this transformation using a chemical equation. Here, the reactant side starts with exactly one carbon atom. However, the product side contains 6 carbon atoms, creating a numerical mismatch. Hydrogen shows a similar discrepancy: 2 atoms on the left, 12 on the right. As it's written, this equation represents a physical impossibility. It suggests the plant is mathematically conjuring atoms out of nowhere, violating the law of conservation of matter. To reflect the actual laws of physics, this equation must be perfectly balanced. We achieve balance using coefficients, numbers placed before formulas indicating molecule quantities. On the reactant side, we add a 6 to both carbon dioxide and water. This yields exactly 1 glucose molecule and requires a 6 for oxygen to balance the remaining atoms. With these coefficients in place, every single atom is accounted for, and the number of elements entering the reaction now equals the number leaving it. The growing tree creates its massive physical structure by flawlessly rearranging the existing carbon, oxygen, and hydrogen atoms it gathers from its environment. A balanced chemical equation serves as a precise written record of these physical transformations. Every chemical reaction in the universe is a perfect reshuffling of finite puzzle pieces, ensuring that nothing is ever truly lost and nothing is ever created from nothing.